Hello everyone, I am Pramod Kumar, Department of Electronics and Communication Engineering from Sagar Institute of Research and Technology. Today I am going to present controllability and observability. Controllability and observability. Controllability and observability represent two major concepts of modern control system theory. This concept were introduced by R. Kalman in 1960. First, controllability. If the state of the system can be transferred to another desired system over a finite time period by using input is called controllability. For examples, input are connected here. Input are connected three systems that input share the system 3, that is called controllability. Not connected input, the fourth system, that is called uncontrollability. Consider the state equations dyt upon dt equal to axt plus but, where x denoted the state variable, u denoted the input variable, and y denoted the output variables. Kalman test for controllability: if a system matrix A has order n into n, then we form controllability matrix QC. Then QC equal to matrix B, matrix AB, matrix A square B, matrix AQB, and dash 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 matrix A to the power n minus 1 into B, yani n into n matrix, where control matrix B must be column matrix. The order of QC is n into n matrix. First, check controllability. The case first, the system is controllable if the rank of QC is n. In other words, when the determinant of QC is non-zero, the system is controllable, that is, determinant of QC not equal to 0. Case 2, if determinant of QC equal to 0 or rank of QC is not equal to n, then system is said to be uncontrollable. यानी टू कंडीशंस है. एक कंडीशंस ये है कि अगर रैंक n मैट्रिक्स का अगर n है और डिटर्मिनेंट, दूसरे शब्द में कहा जाए कि डिटर्मिनेंट ऑफ मैट्रिक्स QC का नॉट इक्वल टू 0 है, दैट इज कॉल्ड कंट्रोलेबल मैट्रिक्स. Case 2, if determinant of QC equal to 0 or rank of QC not equal to n, that system is called uncontrollable. Next, observability. If all the state of the system can be determined from the knowledge of output of the system at given time is called observability. Here all system connected to three system connected to output, that is called observability, and one system is not connected to output, that is called unobservability of the system. Consider the output equation yt equal to cxt plus d of ut. Kalman test for observability: if the system matrix A has order n into n, if the system matrix C has order n into n, then we form a observability matrix Q dash C. Here output matrix C is row matrix. The order of Q dash is n into n. Case first, the system is observability if the rank of Q dash C is n In other words, when the determinant of Q dash C is non-zero, the system is observability, that is mod of determinant of QC not equal to 0. Case second, if determinant of Q dash C equal to 0 or rank of QC is not equal to n, then the system is said to be on observability. Thank you.